All right, so 3 by 3 matrices. With a 2 by 2, you did multiplication and subtraction. And you basically do the same thing with a 3 by 3, but you now have to do multiplication a little bit differently. And so if you'll notice what they did is they have row A, row B, and row C, or column A, column B, column C. And they multiply down, and then they add that to this guy, but you'll notice he ran out of room. And so basically what you do is you bring this top corner down. This guy right here, you bring him down. All right, C1. And then you bring these two down. And so you have like B1, C2, okay? And so when you're multiplying these, you multiply them in this diagonal. And so we multiply this diagonal, and you get that. And you multiply this diagonal, and you get that. And you multiply this diagonal, and you get that, right? And then you group those, and then you're going to subtract the next group. And so now you're actually doing it a different way. And it's hard to see it, but you're actually doing the other way, the other directions. And so they show it to you, C1. So I'm going to start with this guy here, because they do it backwards. The middle diagonal here, that's this guy, right? A1, A3, B2, C1. And then they do this guy, and what they've done is they've brought him up here. And then they do this one, and they've brought these two up here. So, see?
What?
Clear as mud. All right, and so with this method, you pick a column. Say we'll pick, the first column here. And I typically always pick the first column, but I'll show you how it works when you don't. So when you're doing this, there's four, so your non diagonals is what we're going to look at first. I'm going to highlight those. I have this is a non-diagonal, this is a non-diagonal, right? Everybody see what I mean by non-diagonals, right? They're not on the main diagonals. You choose any column or any row. Doesn't matter which one. And then you're going to use that guy to do 3 2x2s. And you're going to add those 3 2x2s together. And so if I choose the first column, so let's say I choose this column right here. All right. Then I am going to take A1, A2, and A3. And I am going to multiply it by a 2x2. All right. And I'm going to add those 3 2x2s together. Now, if I have chosen a row or column that has an item not on the diagonal. So in this case, which one of my 3 is not on the diagonal? Of the one that I chose. A2. I am actually going to make that the opposite sign, whatever it is. Okay? Whatever it is, I'm going to change the sign. So if it's not on a diagonal, I'm going to change the sign. So had I chosen column 2, I would have changed the sign of B1 and B3. Had I chosen column 3, I would have changed the sign of C2. So if it's not on a diagonal, you change the sign. Okay? It's just the easiest way to remember that. Those are the ones you change the sign for. So if it's positive, change it to negative. If it's negative, change it to positive. All right? And then what I do is I create 2x2s. So I'm going to show you what I mean by that. So if I were to take A1, so we're going to just look at A1. A1. All right? I am going to ignore the row and the column that A1 is in. Okay? And I'm going to take the 2x2 of the guy that's left, this guy right here. And we're going to do one of these. So I'm going to do B2, C2, B3, C3. Everybody see how I got him? Okay? Then I'm going to do the same thing with A2. So if I have A2 right here, I'm going to ignore the row and the column that A2 is in. Okay? And I'm going to take the 4 that are left over. So I'm going to say B1, C1, B3, C3. Okay? And then I'm going to do the same thing for the last one, A3.
This makes more sense.
Yes. So if I have A3, I'm going to ignore the row and the column that A3 is in. And I'm going to take the 4 that are left over. And I'm going to say B1, C1, B2, and C2. I'm going to do the little 2 by 2 determinant, very easy, and multiply by this guy. 2 by 2 determinant and multiply by the negation of that guy. And a 2 by 2 determinant and multiply by that guy, and then just add them all together. And that is my determinants, okay? And it actually works out to the same as this. This is just more confusing to me. Like, I feel like that's just more confusing. But you can do it that way if you want to. So, I do it by this shortcut method, all right? And you just create 2 by 2s that we already know are very easy to calculate, right? Multiply them and add those together. All right, so let's do one of these. Let's look at this first one. Now, so specifically, I am going to, whatever row or column I choose, I'm going to be multiplying a determinant by each one of those, okay? And so I actually look for the path of least resistance here. I look for the one that has a 0 or a 1. All right, so honestly, I would choose this column because there's a 0, and I don't have to worry about that 2 by 2 at the end because it's going to times 0. So it's 1 less 1 for me to multiply by. Does that make sense? So if I were to do this one, I would likely choose the first column here. All right, and so we're going to set this guy up. We're going to say -1 times the determinant that's left over, right? Which is this guy. So we're going to say -4, 6, 1, -1. Okay? And then I'm going to say plus 2, but because 2 is not on the diagonal, I'm going to negate that guy. And then I'm going to multiply by the ones that are left over. 3, 5, 1, -1. And you have to do the determinant first, which we're going to do that. And then I have plus 0, and I actually don't even have to fill that guy out. I can if I want to. I mean, it would be 3, 5, -4, 6, right? But it's just going to be times 0 when it's all said and done. And then I'm going to do these determinants. So I'm going to do the determinant first. All right? Think of order of operations. You have to do the determinant first. So -4 times -1 is 4. Minus 1 times 6 is 6. And that's times -1. Times -2. 3 times -1 is -3. Minus 1 times 5 is 5. And then we have plus 0 times a number that we don't care about because it's times 0. All right? 4 minus 6 is -2 times -1 is positive 2. -3 minus 5 is -8 times -2, 16. 2 plus 16 is 18. All right. All right, so in the book, they did -1 times -4 times -1 plus 3 times 6 times 0 plus 5 times 2 times 1 minus 0 times -4 times 5, -1 times 6 times -1, -1 times 2 times 3. Right, and they got the same answer. They got 18, right? All right, for A, which column or row did you want to use?
First one.
First one. All right, so we're going to say -3. We have -5, 1, 2, 3. Plus, we're going to change that to a -2. We have 4, 0, 2, 3. And then plus 0. Just doesn't matter what that is, right? 5 times 3. -15. Always minus. 2 times 1. 2. Then we have 4 times 3. Minus 2 times 0. Right? And then we're going to final. -15 minus 2. And then, of course, 12 minus 0. All right? Question?
Isn't this supposed to be a -2?
It is. Yeah, there we go. There we go. I had it here. I just didn't bring it down. I thought you meant this guy. I was like, no. All right, what's -3 times -17? 51. Plus a -24 should give us 27. All right. All right. So we're going to say 1. I'm going to run out of room. 4, 2, -6, and 10. plus 0, it doesn't matter. Plus 3, we have negative 1, 2, negative 6, 10. Nope, negative 4, 2. I wrote it wrong. Negative 1, 2, 4, 2. All right. We do the determinant here. 4 times 10. Minus, watch your negatives here. Negative 6 times 2. Negative 12. So you are subtracting a negative. Plus 0, obviously. Plus 3. Negative 1 times 2. Minus 4 times 2. There we go. 40 minus a negative 12. Plus, what is negative 2 minus 8? Times 3? Negative 30. So what do we get there? 22. Just like with a 2 by 2, if you multiply two matrices and you get the identity matrix, then you know for sure that you have inverses, all right? It's, of course, more time consuming because it's a 3 by 3, but you're still trying to find out if I have an inverse of each other. And instead of having just a 2 by 2 identity, you now have a 3 by 3 identity. So you're actually looking for the identity that looks like this. All right, has a diagonal all the way across. Diagonal all the way across of 1s. Everything else is a 0. And so that's what you're looking for if you want to verify that these are inverses of each other. You're going to do the same process. You're going to say row by column by column by column. All right, and so you're going to do your matrix multiplication just like you would. You would say 1 times 0 plus 5 times 0.2. What is 5 times 0.2? 1. Negative 1 times 0. Right? And so you can see you're going to have a 1 there. And then you're going to the next one. You're going to say 1 times 0, right? Plus 5 times negative 0.2, right? Which gives me what? Negative 1. And then negative 1 times 1? Plus 1. Going to give me a 0 there, right? Yep. When you add it up, you'll get a 0. All right. And you're going to do that all the way across. If you do it all the way across, you should get, just like we're going to get, 1, 0, 0. All right? And then on the next row, when you do that, you should get 0, 1, 0. Right? And you would go through the same process, row by column by column. All right? And if your answer ends up being this, you can say yes. Those are inverses of each other. If you get any other answer, so if you look at B there, no, those are not inverses. So you're simply just saying yes or no. You're simply just saying, is this an inverse? Is this not an inverse? All right? And it does not matter which way you multiply them. All right? If they're inverses of each other, you should be able to get the identity matrix no matter what. All right? Questions on that?